Well, good evening, everyone, and a very warm, and I mean warm, welcome to this evening's webinar. I hope you're all well and managing to stay reasonably cold in this rather strange weather we're having right now. Welcome to this Media Authenticity in the Age of Artificial Intelligence webinar for this evening, run jointly by the ISSG and FTAG. So I've just got a couple of slides to go through to introduce you to what's going on and the format for the event this evening. So just while I'm doing that, I'm admitting people into the webinar. So forgive me if I just get distracted. So very quick introduction from myself. I'm Steve Sands. I'm chair of the ISSG. Then 6:35, so a couple of minutes time, I'm going to hand over to Adam Leon Smith, who's chair of BCS FTAG. And he's going to talk about really the election context and quite a bit of the ongoing work that BCS is doing in this area, including, I think, some of the international standards work that is going on. So that'll be Adam. And then we'll hand over to our main speaker this evening, who is Dr. Dipayan Bhowmik from the University of Newcastle up in the northeast. We've allowed about an hour for this evening's speaker. To some extent, that'll depend on whether we get questions coming in. If we get questions coming in that we can pose to him during the talk, then we will do so. However, we've allowed another quarter of an hour at the end of the session for anyone who wants to ask questions at the end. So formally, the event ends at 8 o'clock. It may just wrap up a little bit before that. The reason we're here tonight really is because BCS had a policy jam. They have these policy jams round about once a month. And you can see the goal there of the policy jams is to keep members informed on key organisation and public policy developments and upcoming projects. And they're really quite popular. If you haven't seen any, then there's a website that's linked on the page there. And you can go and listen to some snippets from past policy jams. They're very instructional, so highly recommended. This particular one was around fake news, and in particular fake news on the run-up to a UK general election. Now, obviously, at that point, we didn't realise it was going to be quite as close as it has been. In July, we thought probably it would be the back end of the summer. However, here we are, and so we've put this event on to try and address in a bit more detail some of the issues around fake news and deep fakes. And we have an absolutely expert speaker to do that for us this evening. So tonight's speaker is Dr. Dipayan Bhowmik. He's a senior lecturer in data science and an associate professor and the director of business innovation and skill at the School of Computing at Newcastle University. He's one of the lead editors of the upcoming JPEG Trust standard, which expects to positively impact billions of users across the world. I could go on, and in fact, there's a little bit more about Dipayan on the event page that you've all gone through to register. So please do look him up, and I believe there's a link there to his website too. So just before I hand over, a very quick introduction to the BCS for those of you who may not already be members. If you're not, then I heartily recommend it. It is a tremendous organisation, and really and truly, we stand for making IT good for society. The BCS is the Chartered Institute for IT, and if you work in IT, it's a very, very good place to be. We have actually something in the region of 75,000 members now. The bulk of those are, of course, in the UK, but we have representation in around about 150 countries. And up and down the UK and across those countries, we have local branches supporting members in those areas. And we have round about 50 odd specialist groups, of which ISSG, the Information Security Specialist Group, is one. So heartily recommend, if you're not in BCS, please do join. If you're not already a member of ISSG, then similarly, please do join that and you'll get notifications for all of our events. So the ISSG is the largest of the specialist groups in BCS. We have something in the region of 3,500 members, and we're concerned really with all aspects of information and cybersecurity. You can see the list there. It's forensics, it's hacking, it's cloud, it's everything in between. And we're particularly interested in this because, of course, this has a security and a cyber dimension to it. And then just before I hand over to Adam, one more slide to go, I think. FTAG are the Fellows Technical Advisory Group, been around since 2021, and they're made up of 20 BCS Fellows who are all experts in their field. The overarching aim is to explain the opportunities and challenges of emerging technologies, what they mean for the digital industries, and for the competitiveness of UK PLC. So one final slide, just the housekeeping for this particular event. It's pretty much impossible to enforce the Chatham House rule for webinars. So we don't try and we don't pretend to try, but we do expect people to respect any information that we provide in these webinars and to attribute it appropriately if that's appropriate. We have quite a few attendees this evening, so we will be leaving the chat open throughout the Zoom session. If you have any problems or questions, then please do post them to me on the chat, and I'll try and reply as best I can during the event. But if there are really questions for our speaker tonight, then we'll hold them until probably the end when Deepayan can answer them in detail. And if we run out of time, then we'll simply copy all of the questions that we haven't been able to answer, and we'll send those Q&A out to all of the attendees at the end of the event. The final question, the one that we're always asked, are we recording the event? Yes, we are. The event will be available on the RSSG website. It usually takes about 10 days to a fortnight. So if you want to review the material this evening, have another look at the slides, then you will certainly be able to do so. So I'm going to stop the share at that point and hand over to Adam.
Thank you very much, Steve. Thanks for that introduction. So Adam here, chair of BCS FTAG, the Fellows Technical Advisory Group. As Steve was outlining, BCS has been doing a number of things around this deepfakes issue. And that started from a policy jam. It's also included a survey of members about the potential impact of AI deepfakes, specifically on the UK elections. I guess we didn't know about the French elections when we did that survey, but they're beating us to the past the post, if you like. One of the things we found was that 65% of people did worry about AI-generated fakes affecting the democratic result in the UK, and 92% of the members we surveyed said political parties should agree to publicise when and how they're using AI in their campaigns. About 8% of people that responded are confident in big tech companies coming forward and having code of conduct and things to manage some of the risks of AI without supporting technical controls. And in this case, I was pleased to find out that there are international experts working on protocols like JPEG that we can make safer for people to use and build trust in those existing protocols. One of the things we do at FTAG is to monitor the BCS representation into international technical standards. We don't have anyone on the particular committee doing this work, but we became aware of it through some other channels and thought it'd be good to pair this more technical initiative with BCS's policy initiative in this space. Whether protecting democracy falls into the realms of cybersecurity or information security even is debatable, but I think these days any danger to people's safety and rights is sometimes argued as a cybersecurity issue. And also we don't have a specialist group for protecting democracy, so this was definitely the right specialist group to do this talking. So without further ado, I think I could hand over to Dr. Deepayan Baumik from Newcastle University to take us through the project. Welcome, Deepayan.
Thank you, Adam. Thank you, Steve. I'll try to share my screen and then I will start. Right, is that something coming out okay for all of you?
Yes, that's great, thank you.
Right, okay. I think Steve gave the introduction, so I'm not going to go into details. So just to mention, I'm in Newcastle. I'm with the University of Newcastle, and I'm going to start with some of these things. I'm going to ask you actually with one of the questions. So we talked about fake images, right? So to the participants, what I'm asking is, what do you think, which one is real and which one is fake? the way you could respond, if I'm saying the left one, just put your hands up, and then I will ask the same question for the right one as well. So just look at these two images and say which one is fake. Go for the left one first. Do you think it is real? Okay, let's put this back. How many of you are thinking this is fake, the left one? Some of you, I can see. Right, okay. And how many of you are thinking the right one is actually fake? Okay. Let's find out. Actually, both of them were fake. So this is the first one. And what we have done? We have changed the area. You can see actually the bed area and replace it with some contextual information and got something quite convincing. And the other one was also fake. And again, the one in the middle was the original image. We have had a mask around it, and then we have changed it. Now, in this context, where I would say and the manipulation and the image manipulations, they are being so realistic that it is nearly impossible to understand and look at it and identify whether they are fake or real. And that is the problem. And that is the problem why that is all of us are aware that is spreading fake news or something, a false impression, etc. Now the question is whether this problem is new. They are not actually. The image manipulation, if you go back in the history over 150 years, you actually can see this is happening throughout our history from the point when we have had pictures taken, and especially it has started growing up when there has been options for digitization. So it started with, say, 1860 with Abraham Lincoln. Lincoln's head were added on top of Southern politician, John Calhoun's portrait, and similar things happen with Joseph Stalin, Canadian Prime Minister, Soviet soldiers, Oprah Winfrey. So in different stages, sometime it's to make the political leaders to showing it off. Sometimes they don't want to see themselves with somebody else which can put their position slightly down. Or in case of Soviet soldiers, you can see in 1945, the Russian magazine removes the watch from the soldiers' trade to ensure their readers don't think the soldiers are looting. And that thing is kind of going on in a number of different cases, and these are some of the snapshots. And then around 2020, 2018, 19, 20, 21, deepfake came in picture and quite prominently. And it is so much an issue if you search for these deepfake terms on Google or the Google News. I've done just a quick one this afternoon. You can see it is all over the places. Political deepfake list, malicious AI use, DeepMind finds. And then explicit use in the student cases, propaganda videos is getting tougher to detect, and all sorts of cases are there. And if you do the similar search with image manipulation, you probably will get a similar answer, but it's all over the places. And it is really almost attacking our principles, our beliefs, and the trust. And I will come back to that on the word trust in a moment. Again, this is a search result by me this afternoon using Bing News. This Bing News came up with two different type of perception. One is saying there is no obvious editing of one of the recent photos by Kate Middleton's Father's Day family photograph, and the other one is actually doubting about it. So with the perception of having deepfake and AI generated or AI manipulated images, it has been so difficult. Now people have started thinking and doubting every image that is coming up. So it has got kind of two different problems right now in our hand. One, yes, there are some intentional editing that is going out for mis or disinformation purposes. And kind of everybody is trying to find whether they can detect it and make sure this is genuine and trustable. But at the same time, that actually made the right damage to the society, that nobody is trusting anything they see on the digital media. And now there is the point how we can make sure that the trust is back. The impact of media manipulation, they are huge. Political, we talked about different political scenario with Steve and Adam said about the upcoming UK elections, but it has been proved to be a tool that has been used across the world for any different types of elections, sometimes to glorify politicians, sometimes to defame them and to gain some political advantage. It has been used in the social context quite a lot, and from the influencer to very highly influential people to defame them or to earn their some fame in some way. And it has got a direct economic impact, and that is happening quite massively across the world. So if there, all these things are kind of quite crucial to understand that. In this presentation, what I'm going to do, I'm going to show you some of the recent research we are doing at Newcastle University. That's the first part, understanding how easy it is to manipulate images or videos, and what are the different ways you could do that, and what are the different types of detection, or how do we tackle them from the technological point of view. Once we understand that context, we will pretty much move on to something called the international standard, which is called JPEG Trust, and understand what we are doing in the JPEG Trust and why we're doing so. How easy to create manipulation? So, as I mentioned, there has been a long way going back in the history, people are doing image manipulation. But probably right now, it has been much more perfect, and it went from the experts to the general user to create manipulation. This is one of the organized way we put things together. We are creating a large data set which involves using generative AI, how much you can do the manipulation. What are the steps here? We have almost automated the process. So you have one input image, we automatically detect what are the different segments or areas we want to manipulate. We generate mask, we generate a description of that image through other machine learning models, including ChatGPT. And we actually replace some of the terms, and replace some part of it with something different, or just remove that object from the scene, or doing a combination, or introduce a new object in the scene. And all these things are mostly being done automatically through the prompts. And once you have that prompt in, then we are using other generative AI models, which are using GAN, Generative Adversarial Network, diffusion models, and the other models to have those manipulations. So primarily we have categorized it into 3 different parts: a removal, replacement, and the creation, or a combination of 2 of them or all 3 of them together. And these are some of the output images you can see. Why we are doing that? Because this is very important for us and anybody else who are doing research to have those data sets to play with it so that they can come up with new algorithms that can automatically detect it. And these are some of the examples you can see. The top row, that's manipulated, then the original ones, and then what was the mask. I'll give you some moment to look at it carefully. So only one thing I would like to say, things have been very, very near realistic. And that is the problem, I would say. It's good for many various purposes, but for the problem we are facing, it's really, really bad. And everything, a very simple user without having a lot of knowledge, they would be able to do that fairly quickly in seconds, and they would be able to set up these tools even in an extremely easy way with all the advancement that has happened over the past, say, 1 year or many years, but over the past 1 year, it has been pushed quite a lot. So you can see in the first column, the person's legs and some part of the body has been removed. So is the giraffe has been replaced, persons removed, and the bags were kind of gone. Not all of them are perfect, but it is getting closer to that, and it is getting closer to their being mingled with the context or the other environment within that image and the context itself. So that is one side of the story. Now think something even more problematic. This is in the satellite imaging space. The satellite imaging space, now, these are not a huge problem at this point, but this is coming. And this is why we are kind of trying to sort out what would be the answer. There has been quite a story when at some point people used to believe the newspaper articles, then those days are gone. Nobody is going to believe truly unless that is coming from a good source. Until now, people used to believe images and then videos. They have got their integrity and they can believe them. And this is somehow that trust is diminishing. Satellite imagery is the next in line. People are thinking satellite imagery is kind of very genuine source of information. But as you can see here, that complete airstrip can actually be manipulated and then showing that there was no airstrip and with some ruins or something. And how do you handle that? This is a slightly different problem, but in the base of the problem, they're kind of the same problem. It's the image manipulation, but the context is slightly difficult and different in these cases. I think with that, we have got enough idea. The image manipulation is really a problem in multiple different fronts. And we need to do something from all of us, actually. All of us are stakeholder in that, from the technology development, but adaptation of the technology in the society, integrating them through different tool sets are also quite important. So what we do, we divide them into 3 categories. One is the detection algorithms. Yes, we need to have a very good, robust detection algorithm. And there are kind of a couple of different ways we could do that. One is digital watermarking, which is the active way of you insert some information within the image itself when you are generating, and with the hope that that watermark information itself is going to stay there throughout the lifetime of that image or video. And a passive way of detection is without having that watermarking in it. You are looking for some traces within the image itself, and using the, say, deep learning based algorithms, you are trying to retrieve those information, which is going to show you possibly to say this image, this image has been manipulated, but also where the manipulation has happened within the image, the localization of the manipulation to be detected. Now, one of the problems you get is if the algorithms are working on its own, there has been lots of algorithms across the world. People are working on that. But unless you have a framework that is integrated in the pipeline, it is of no use, because nobody can actually, general user can take those algorithms independently, and people are not probably technically hugely sound to make those compilations together and put that as a form of software to understand whether this detection algorithm is there or not. So what we think is kind of another better way to do it is creation of frameworks. And in that framework, you can have multiple components, starting from your image, going through a pipeline, and to produce something as the output, which either will say visually this image has been manipulated or not been manipulated based on certain information, and the output is going to be given. Even that is not enough. And this is where the standardization comes in picture. And JPEG Trust is one of them who is leading in this domain, how to standardize so that the image manipulation techniques or the information about the media provenance, authenticity, and integrity can be verified in a much more easier way and with an interoperable way, so that anybody can actually operate as long as they are complying with the standards. I'm going to give you a brief introduction to both digital watermarking and deep learning based methods before we jump onto JPEG Trust. Say this is watermarking. Where what we want to do is putting the information inside the image or the video, inside the content, in a way that is invisible. I have used my alma mater logo, University of Sheffield, where I was doing my PhD. So it's kind of the way you structure it. You unfold this watermark information and then try to find out automatically within the image itself where there has been lots of texture. We try to modify those pixels or the information over there so that this is not visible. Because if I draw a line on a white background or white wall, this is easily visible. But if you draw a line where there is a picture of a tree and tree leaves, they having so many textures around it, the small changes are not noticeable. So that is the kind of core principle when you do watermark embedding. And think about watermark as in your currency note, there is always watermark in all currency note across the world. You can only see the watermark if you do a special processing. In case of currency note, you take it under the light. But similarly, you do it with algorithms. And when you actually extract that information, you will see on the right-hand side, the information has been spread over at different places. And then when you extract them back, you can actually extract the information you put in. In that context, I will say you something else. In the signal processing community, we say compressive sensing is a signal reconstruction from the randomly sampled images. It's mathematically proven signal processing theory where you can actually reconstruct images from a very, very small number of samples of the image itself. And you can see on the left-hand side, the image reconstruction has happened from the 40% of the sample. So the top rows in both cases are the samples we have taken. Then we actually use this compressive sensing technique to reconstruct it, which is quite there, quite almost there. And similarly, On the right-hand side, and this is even less number of samples, like 10% of the image samples of the image pixels has been taken and been reconstructed to find out, to reconstruct the image itself. Why this is important? What we actually did, we have taken the signature from the original image itself, very random samples, and use that as the watermark and embed that within the image itself. And what is the advantage around it? When you can extract the watermark, you actually can extract what was the original image. And once you have understanding of the original image, you can compare that with the image you received, and then you can check the differences and you can find what is the problem. And at the same time, we introduced a concept of media blockchain, where in the blockchain itself, all the informations about copyright information, ownership information, and what sort of modifications were done is kind of there in the blockchain, so that you can actually retrieve that information from there. And the connecting bit is the information you put inside the watermark, which is connecting to the blockchain and retrieve those information, and to have some understanding of the authenticity of the image and the provenance of the image. And these are some of the results we recently we're working on. Our framework is called TRAIT, Trusted Media Distribution Framework. So on the left-hand side is the original image, and some modifications were done. And to the extreme right, we are kind of showing that it is possible using these methods to extract and identify that information where the modifications were done, and in a localized form, yes, if there was a modification that was done. Then it is coming another way to detect it. It is kind of deep learning based. Now, I have taken one of these figures from one of the published papers, not by us, by other researchers, very recently, which has been very successful. We're detecting the modifications in different forms. And in a typical deep learning architecture, there are something called encoder, and it is a multi-scale encoder. It is taking care of the noise print and the Bayer conversion and all different parts and different elements and the context as well. And there has been anomaly detected to find out, and finally it is identifying whether this has been detecting properly or not. Now, what we are currently working on is something more advanced than that, because even state-of-the-art detectors right now, they has not been successful in identifying any detection by generative AI modified content. Some of the images I have shown to you in the sometime back, few slides back, the dataset we have created or creating in the process, they cannot handle it yet. And what we are trying to do is kind of coming up with answers and the detection algorithms which can do the similar job. So with the introduction of generative AI and the synthetically generated images and the manipulation, is actually changed the complete detection algorithm research quite widely. And this is where everyone is trying to make working so fast, and because things are changing so fast. Now, on the third part is JPEG Trust, is about the standardization. So we can do lots of things individually. We can propose different algorithms. We try to say this is best in the line and this is state of the art, but it's kind of quite well understood. It's a cat and mouse game. I mean, nobody can have a single detector which is going to stay there forever. Every now and then, if anybody is claiming that I have a best detector in the world, it is robust enough, within few days time, they would be kind of gone, because the way of modification that is changing super fast. And also people are trying to do different way of modifications and different techniques that is being used. And also the trouble is, if I develop one of the detector, I cannot reach out to everyone in the world to use that. And that problem can only be solved if there is a standard. And this is where JPEG Trust came in. Just a slight brief background about JPEG. This is Joint Photographic Expert Group. Over 30 years, almost everybody now is using .jpg file types for their images, or .jpeg. So these are the image coding standard that has been standardized quite well 30 years back, and still very much in use, and majority of the image file formats are using JPEG. So I am part of that JPEG committee, and particularly we were discussing about fake media sometime back around in 2018 or 19. And after that, we were working on JPEG and the blockchain and the fake media in general. But really that has been picked up after 2020, when we saw lots of interest and lots of fake media problems started appearing. At that point, we went out to different stakeholder groups across the world through different workshops we organized to understand the requirement, to understand the use cases. And at that point, we had established a ad hoc group who were looking at this problem in a closer view, and then trying to propose how we can come up with a standard which can actually support the stakeholders across the board, starting from the technology companies, platform providers, to the general user. And JPEG Trust, or this is part of ISO, International Standard Organization, and that is supported by national bodies. Like within UK, there is British Standardization Institute. They directly feed into it. So my participation is through through BSI and to JPEG ISO standard. Now, during this process, what we have found out a list of requirements by different people. And once we have finalized those list of requirements, then we opened up a call for proposal, where there has been responses to the call for proposals. One of them is from Adobe or C2PA. I'm not sure, some of you probably know about C2PA, Content Provenance Association, who are a consortium of a good number of industrial partners, came together to solve a similar problem, and they have a specification with C2PA. Then Huawei Technology, they have been concerned about this, and they have been involved. Sony has been involved. IMEC and the Vrije University in Brussels, they have been involved. UPC Tech in Barcelona, they have been involved, and us from Newcastle University, we submitted another proposal as well. But these are the kind of formal proposals we actually made into in response to the call. There has been a lot of participations from other organizations throughout this activity, and to come up to kind of work together. So when these calls, the responses were actually received, then there has been a consensus between all stakeholders. Let's work together to have this standard a right one and a powerful one. In considering that standard, we have some use cases. Now, here is the kind of striking point. The media manipulation, with the advancement of the technology, it's not all bad. I mean, most of the time we see through things with the kind of focus on how much bad thing has been done in order to do misinformation, disinformation, dissemination, media forensics and forgery, etc. But there is a huge positive impact in the society, particularly within entertainment industry. The generative AI and all the advancement that has happened within this region that has been helpful for media creation and the media modification as well, which otherwise would take a huge amount of time, kind of manual labor, hours of manual labor using Photoshop or editing softwares, which are kind of very important to do all those changes. And under those kind of broad 4 different areas, we have lots of different application areas. So on the left-hand side, which are mostly focused on what is going bad and with a bad intention. So media uses in breaking news, deepfake detection, content authenticity checking, content usage tracing, etc. Even fraud in academic research that has happened, and photographic framing. In the media forensics, you can see the insurance fraud. That is one of the largest market at this point. Just to give you an example on the insurance fraud, in the insurance industry or even in the banking, what has happened, the insurance company, they want to see the evidence when somebody is trying to claim their insurance for, say, a car accident. And that information is being forced to claim the insurance and get the money. And that is turning into a £1 billion industry. And then also in the banking, the know your customer KYC, not so much in the UK, but across the world, for the banking purposes or any financial transaction purposes, people need to have their identity document, and that identity document is being forged or can be forged. So those are the kind of the problem that is coming out of that, and including evidence of a judicial trial. But on the right-hand side, that has been very useful for movie special effects, movie transcoding from one format to another format, colorization, like when you have black and white images and then suddenly you want to do a whole new refresh on the black and white images or videos with the colors. Photo editing has been quite simplified. Like if you has been exposed to Adobe Firefly, some of the new tools, they are AI generated and they can do the photo editing much more quickly and much more in a better way. Another example I can imagine is which is having very much in the advertisement industry. People are actually creating the advertisement without having a physical models or having to employ photographers. So they're kind of good and bad things. So what we want to do is, within the scope of JPEG Trust, is to provide a framework for establishing trust in media. So this framework includes aspects of authenticity, provenance, and integrity through secure and reliable annotation of the media asset throughout their life cycle. So what is mainly happening here, this is the annotation or the metadata information that is going to sit within the image itself in a secured way, so that who is decoding that information, they can actually derive whether they can trust that particular media or not. And this is why this is crucial, and it has to be in an interoperable way. And JPEG Trust is doing exactly providing that that part. So far, in the JPEG Trust, the part 1 of the core foundation is expected to be a standard later this year, because lots of work were done. Now it is under the approval part from different national bodies from different countries, which we are expecting their approval, unless there is something big has happened, by end of July. So then with some more editorial changes, this standard is going to be available later this year, and with some implementation as well, so that the companies or the industry can take them forward and implement their own version of it, which is compliant to the standard. Within the core foundations, we have got, of course, the terms and definitions. The entire framework has been described. And in between, there is something called media asset lifecycle annotation. I will come back in a moment. How do you embed those information within the media? How do you identify of the asset and the actors? Actors means who actually are operating those media assets, might be the cameraman and then post-processing person or the signing authority. Say something like, if BCS is saying that I sign, this is through our authority, so that people can trust in it. So these kind of informations, how they should be doing, and then it comes with media asset authenticity and the integrity component, where there is no single detection algorithm is defined, but it has actually defined how to use the new algorithms or any detection algorithm. And that information is going to be part of the metadata itself, so that the extraction of that information and the final understanding of the trust can be carried out. It also comes with trust indicators and threat vectors. In the threat vectors, it's typically saying what sort of manipulation it could actually have and how we can handle them, and what are the trust indicators that actually identify these are the information that is actually useful in order to trust in it or not trust in it. And this is probably one of the important piece of figure. This is called JPEG Trust profiles. Now, this is kind of a very important concept. So the trust in the media or trust in the image itself, it may mean differently to different organizations. Okay, I can give you one example. Say I'm going to take the same example of insurance fraud. So in the insurance fraud, some of the information, when that image was taken, where that image was taken, are important, because those are the time of the incident, geolocation of the incident. Those are very important factor, and they are kind of very important trust indicator by insurance companies. So they may have a profile that is needed to be checked, or that needs to be matched against those important trust indicators. But these trust indicators and the profile could be different for somebody else. Let's say in the publishing industry, like any news channel, who would be interested to know if that media was modified at all or not. If they have been modified, who modified that, what has been modified, and also probably where this is coming from, and this kind of the provenance information that is interesting for the publishing industry. And similarly for, say, the government policy documents or any other documents, they may have a different trust profile. So what this JPEG Trust is actually providing from the media content, from the metadata, from the provenance information, they're going to provide a bunch of trust indicator. And then depending who the organization is, they have their trust profiles match against it. And to produce, there's going to be a calculation inside, and that's going to produce something called a trust report. And that trust report is going to say in a very transparent way, these are the trust indicators, and this is how we have calculated it, and this is my score individually against each of these lines, and collectively, this is my final score. And that score could be something between 0 and 100. And based on that 0 and 100 score, you can have color coding, something like green, it's all good to go, or it's red. So if it is not there, so it's probably may not be trustable. But what the standard is doing, they're not imposing, they're not taking the final decision. The final decision is with the user, whether they want to trust a media asset or not trust it, based on their judgment by looking at the trust report. What we are trying to do in the JPEG Trust is trying to provide a way to produce that report in a kind of agreeable way. And this is where this particular piece of figure is so important. I'll go into slightly more in the media lifecycle annotation. You can see there are kind of lots of different arrows are going on. So one media asset, these are these contents, this is the content, the actual media itself, the metadata, additional information you may have within that or may not have within that. And then finally, trust record. It started with some of the informations like cryptographical hash or whether an indicator of whether this is generated by AI generated content, AIGC or not. All those informations are going to be there as assertion. And for those assertions, there are going to be some of the additional information, how the media has been created, who created that, when, where, and then also the intellectual property right information. And if there has been some actions or the modifications were done in this pipeline, one of the example is if you're using Adobe Photoshop, so that should automatically insert those informations, what sort of modifications were done, whether this is transcoding, contrast changes, brightness changes, or whether this is a global modification or the local modification, and what is the region of interest, or even purpose of the modification. So these are the sort of information, and then a prototypical information, metadata information like EXIF, IPTC standards, XMP, those are kind of part of those assertion. Now you can imagine, you can say that this information somebody may not want to include. Well, that is absolutely fine. But when you are trying to trust media content or not, these are the indicator. If you do not have any information about this, all of this kind of assertion, you may start believing this may not be trusted. That is how you can see how you can use this standard against when you have the report generated and finally taking the decision. So this is one of the use cases, AI generated content, AIGC. How do you want to find that, whether this image has been generated using completely synthetically or been manipulated? So the creator here is creating this media asset, which has got, again, the media asset content, other metadata, trust records. The extraction algorithm or the JPEG Trust implementation would try to find the trust credentials. So the media classifications, the EXIF informations, which can include probably the camera make, model, the hash informations, and something called digital source type defined by IPTC, how that has been generated, whether this is generated by a camera, whether this is generated completely by algorithm, or whether this is a kind of mix of both. You can think of mobile phones these days. There are multiple cameras and there are processing element into it before you can actually see the images, which is very nicely represented in front of you. But the processes has been there, and then how much of that information is actually captured there. And then it is compared against the trust profile. We talked about the trust profile, and we'd like to see if there has been any modifications. There might be multiple modifications, how they have been checked against, and if this information is AI generated content or not, already declared by the creator, it probably or not. Or if that is not declared by the creator, and then what are the other sources of information indicating? Like if EXIF information is indicating a camera source type or camera type, then that means it is less likely to be a AIGC or the AI generated images. So all these informations come together, it matches against this trust profile to provide the trust report. A, it could be not modified, B, an answer whether it is AIGC or not. Now, these are the use cases. They're extremely important, and different government across the world, they actually put in place the policy, and the technology providers, they have to say whether the media assets, they are either created by themselves or they're distributing through their platforms, are kind of verifying whether the information is AI generated or even AI modified these days or not. And this is where everybody has to comply with. And this is the whole point of having this standard, and JPEG Trust is one of them leading this kind of activities across the board. Is that end of it? No, because this is ongoing process. So we managed to have the core foundation of the JPEG Trust, and that has been circulated for approval. But in the meantime, we are also working to extend JPEG Trust framework over the time, and the extension right now under consideration. How do you register assets or the actor in the system so that everybody knows there's some information is there, and that's going to be part of the metadata within the asset itself, and some part could be part of some repository, which could be centralized or decentralized repository. And also, how do you, or whether it is possible to have version control, because that is something is very easy in the text or even digital coding, but for the visual content like images or video, it's not that easy. And we are also quite actively working on a standard on NFT. And these are the few things we are considering, and more information and the types of requirements that is coming in, we do carefully consider them. And with consensus, we like to work towards the standard to be extended, which might be useful for many or the billions of users we are hoping. And finally, I can give you this information about JPEG Trust. You can take a note that jpeg.org/JPEG Trust. If you go there, or if you can actually just search for JPEG Trust, you'll find lots of information, and quite a lot of them are in public domain, including some of the workshops we ran over the last few years, and the workshop materials and the presentations from different stakeholders are present there as well. So you can definitely go and see all those things, and definitely you can ask the contact over there, or even me, if you like to know more and how you could be involved, because we really like this standard to be successful one, which we believe is a useful one for the society. And with that, I would probably stop now. So this is me, and this is my email address, where you can send email directly to me if you have questions. And of course, I like to acknowledge and thanks my collaborators across the world, the research associates, PhD students, or even masters and undergraduate students sometimes they work on. And of course, the funders, EPSRC, Digital Catapult, I worked closely with them, Airbus, and also I'm part of JPEG Trust. So I guess I have been able to give you some sort of understanding of the media authenticity right now, what is the scenario across the world, especially with what has happened after generative AI came in force, and what is happening with the standard JPEG Trust, which is one of the most important one. And with that, I'm going to stop and quite open for any question.
Hi, Dipayan, that was fantastic. Thank you very much indeed. That's been very thorough. We've got a few questions coming in. I'm just wondering what the best way to do this might be. I'm going to try and open Charles. He's muted at the moment. Charles was asking about a content authenticity initiative and C2PA. Now, I know you referenced that on slide 19. I'm not quite sure whether you've answered his question completely or not. Charles, are you able to speak?
Sorry about this. Unfortunately, not at the moment. Sorry, I've got a youngster in the lab. Sorry.
No problem at all.
That's fine. I'm going to explain a little more what's the relationship. So C2PA has been quite actively involved from the beginning of this standard, and we are jointly working together. We do not want to create multiple different standards, and that's going to be very, very horrible for everybody. So what we have done is the interoperability between C2PA and JPEG Trust, so both of them can handle each other. So I hope that answered your question, Charles.
Thank you very much. Yeah. It's just that this is the first time, because I'm a photographer, and I see one of the areas that can sort of I keep an eye on is making sure the photos don't get taken. And as somebody said a while ago, the best way of making sure of doing that is not to post on the internet at all. But then I've seen these new initiatives starting coming up, and it's sort of it's very easy to get your stuff taken, but then I didn't know about JPEG Trust, so I'll be looking into that one, and the research that I do as well, I'll be looking into that one. And the main one I've heard is the initiatives I've heard are Sony, which you mentioned in your slide pack, and the C2PA and the content authenticity. So I'm just starting in this area. I'm starting to look into it more, but it does interest me because I think we like to, if we want to share, we share. But if we want to sort of protect our stuff as well, we want to be able to individually be able to protect our stuff, then that's important. But obviously from this perspective, where you're coming from, it's from an industrial perspective and from a media perspective, things like that, and obviously deep fake. So I'll shut up. Thank you very much for answering that one. Thank you. And I've got a youngster next to me again.
Sure.
Apologies about that. I will leave you to it. Please, I'll keep on listening and mute. Thank you very much. Thank you.
Thanks,
I'll
Charles.
just add slightly on top of that. We are also quite aware that people from creative industries, including photographers, are very worried about the copyright of the images they have created by themselves and being used by the large organizations for the training of the machine learning models. So we are very aware of that position, and we are making provisions. We actually made provisions to declare your image can be used for the training purposes or cannot be used for the training purposes, or somewhere in between. Yes, it can be, but with some conditions on top of that.
Brilliant. Thank you very much. We've got a question now from Gary. I don't know if Gary's going to be able to speak. I've asked him to unmute. I'll read the question out in the meantime. So Gary says, do you see us ending up with a JPEG equivalent to the various SSL or TLA or the certificate authority schemes that we have for PKI, providing unique keys to camera makers at an individual device level? So does this need a whole bunch of new infrastructure, I guess, to build up that trust framework?
So no. So the way standard works, and especially in case of JPEG, we try to define the standard, and we do not own any infrastructure or the final commercial implementation of it. It's a similar way the regular JPEG images work. There is a standard definition. There is kind of very much technical details into it, but any encoder and the decoder, or the compression or the decompression, and that is done by individual organizations. So any mobile phone, if they have a small algorithm running to compress it into JPEG, or even for viewing, if you're using a JPEG decompression algorithm, or even on your television screens or the monitors or any kind of media you want to see, they implement it. It's the individual organizations. What we make sure we give this a standard so that everybody can interoperable. So a compression done by one company can be opened up by another company without any problem, with the seamless things. So similarly, for the certificates or the key generation, we are not the organization who are going to own that authority. We will leave it to the individual organizations or a group of organizations to take care of that.
Thank you. Brilliant. Adam's next. Adam, you can unmute yourself, I think.
Yeah, I can. My question was about implementation after all the national bodies have voted for the standard. Do you have an idea of what the industry implementation looks like? Does it start at the hardware level, or is it something that happens in software first? How do you think that implementation will look?
So in our roadmap, we are actually started working on a reference software so that we can give it away. And that's going to come up in a 3 to 6 months time frame. I'll take a kind of a slightly reserved way of 6 months time frame that's going to be available for everybody. And gradually, we are hoping the industry to have those implementation adopted by themselves when the standard is fully out, because it is not fully out yet. So this is what in our pipeline or the phases that is happening.
Thanks, Deepan. Great presentation. Thank you for tonight.
Yeah, brilliant. Thank you. Cheers, Adam. James, I want to know before you ask your question, is that a real image behind you, or is that something you've created yourself? Can you unmute and ask a question?
I believe the real image. It won Wildlife Photographer of the Year award, and I believe they did do certain checks on the images they took. So it's a cut and paste of that with no Photoshop whatsoever
that we know of.
Yep. So my question is, thank you very much, Steve, for that talk, Deepan. But that was all in the context of JPEG. What about moving pictures and MPEG and so on?
So there has been some activities that is going on in general, and next month we're having the meeting in Japan, where we are kind of trying to have all hands together. And in a very recent conversation from different head of standard organization bodies, they want to create a single interoperable standard. And this is pretty much under discussion, that we have kind of 1 or 2 standards, not from different organizations like JPEG, MPEG. In terms of the principles, of course, we are part of JPEG, and through ISO, we are mandated to work with the static content or the images, not static content. But at the same time, these standard can be easily extended for moving pictures, documents as well, because that's also another big area where authenticity is quite needed. We will probably see more joint up approach in this domain, and that is already under huge discussions elsewhere as well.
Thank you.
Thanks, James. I had a question just while we're waiting to see if there's any furthers coming in on the chat. So if we go down the distributed ledger or the blockchain route, Deepan, who will operate those, and how will we trust those operators of distributed ledgers for image trust purposes?
That's a good question. I do not have a proper answer for that, although I worked in this area. It has got 2 different components. Okay, so for the JPEG Trust, or the standard itself, doesn't need to rely on a distributed ledger fully. It can have its own information, all self-contained within the media itself, and then it can go ahead and do the job it is intended for. But the distributed ledger is going to be very much complementary and important with that context as well. And to my best thinking, it's going to be a small group of number of distributed ledgers, not a single master ledger for the entire world. And at that point, there would be, say, a distributed ledger for publishing houses, or somebody like BCS can organize that with input and resourcing from different organizations, either within UK, outside UK, and there will be pockets of distributed ledger in that sense, what I can think of.
Brilliant. Thank you very much indeed. Do we have any more questions from anyone? If you want to stick your hand up, if you don't want to type it into the chat, we'd be happy to take questions from the floor. If you want to raise a hand or send me some kind of signal. Gary has asked another question. There are obviously methods available already for verifying file downloads using hashes. would it be simpler to ensure that devices generate similar hashes at the time that the photo is taken?
Okay, that's a nice question. So there are two types of hashes. One is the file hash. All of us we use for different purposes, sending any files. The trouble with file hash in the visual content, if you change anything, even a single bit, it's going to generate another hash. But in the visual sense, you may want to change a few things, even changing from JPEG to PNG. For example, it's the same image, same content, but the file type has been changed, nothing else. So in that case, file hash is not appropriate. So what is important is something we call perceptual hash or the content hash. In the standard itself, what we are allowing to have both hashes together when the image was taken, one hard-bind hash, we say that, which is the cryptographical hash for that file itself, are going to be part of the image itself to start with, to answer the first part of your question. But along the way, we are also making provisions to have soft hashes or the soft bindings or content hashes, because that is equally important in case of the visual content.
Brilliant. So a combination of hashes used for different purposes then, yeah?
You can think of there is no single answer to kind of whether you can or cannot trust. There are kind of lots of different components come together, and that is going to give you a report you may or may not want to trust after seeing that.
Sure. Gary says, excellent, thank you. Gary, if you've got anything else you want to ask, then I'd be happy if you unmute. And similarly, anyone else? That I can't see any hands up or further questions coming in at the moment, though. So we're just on 20 to 8, which is great because it's a very, yeah, thank you for a very informative presentation. Worth waiting again and following up on the references. So the whole presentation has been recorded, and within probably 10 days to a fortnight, we hope to post that on the ISSG website. So you will be able to go and look it up and refer back to Dipayan's presentation and slides. But in the meantime, I think I would just like to wrap up on this very, very hot evening by saying thank you very much indeed to Dipayan for giving up his time and sharing his knowledge and expertise with us. And of course to Adam, Chair of FTAG, for really having the idea in the first place of following up that policy jam session that was very successful and raised lots and lots of very good questions in the run-up to the general election, and having that idea to run this session and cover off this particular topic. So that just falls to me then to wrap things up, say thank you to our speaker, and thank you to everyone who turned out this evening on a rather warm evening. Probably a good time now to go and get a nice cold drink. Thank you again. Bye for now.
Thank you very much.
Thanks for organising, Steve.
Thank you.
Thank you very much.
Bye-bye.